Let's delve into the world of proxy servers. In this presentation, we will explore both forward and reverse proxy configurations. Proxy servers act as intermediaries between clients and servers, providing various benefits such as security, performance enhancement, and control over network traffic. We'll start with the basics, understanding what proxy servers are and the roles they play in modern network architectures. A forward proxy acts on behalf of clients, forwarding requests to target servers while hiding the client's identity. On the other hand, a reverse proxy sits in front of servers, intercepting client requests and distributing them to appropriate backend servers. A forward proxy sits between client devices and the internet, acting as an intermediary for requests from clients seeking resources from servers. Think of it as a middleman that receives requests from internal clients and then fetches resources from the internet on their behalf. Let's look at some key characteristics of forward proxies. They hide client IP addresses from destination servers, providing anonymity. They provide access control and content filtering, allowing you to block specific websites or content. They also enable bypassing geo-restrictions, allowing access to content that might be restricted in certain regions. Forward proxies cache frequently accessed content, improving performance by serving cached content to clients. They are configured on the client side, meaning each client needs to be set up to use the proxy. Let's explore how to configure a forward proxy. We'll examine configurations for both the proxy server itself and the client devices that use it. Here's a basic SQUIT forward proxy configuration. First, we define the HTTP port on which the proxy will listen, in this case port 3128. Then we define access control lists or ACLs to control network access. Here we allow access from the local network, that is 192.168.1.0/24. We also define secure socket layer ports and safe ports. Finally, we allow access from the local network and deny access to unsafe ports. To configure a client, for example, in Firefox, navigate to Settings, then Network Settings, then Manual Proxy Configuration. Enter the HTTP proxy address, such as proxy.example.com, and the port number, such as 3128. For the Linux command line, you can export the HTTP_proxy and HTTPS_proxy environment variables, setting them to the proxy address and port. To use curl with a proxy, use the --proxy option followed by the proxy address and the target URL. A reverse proxy sits in front of web servers and forwards client requests to the appropriate backend servers, returning the server's response to the client as if it came from the proxy itself. Unlike forward proxies, clients are generally unaware that they are communicating with a reverse proxy. Let's explore some key characteristics of reverse proxies. They hide the backend server infrastructure from clients, protecting the internal network structure. They provide load balancing across multiple servers, distributing incoming traffic to ensure no single server is overwhelmed. Reverse proxies add secure socket layer or transport layer security termination capabilities, decrypting incoming traffic and encrypting outgoing traffic. They also enable caching for improved performance by storing frequently accessed content, and they are configured on the server side, simplifying client configurations. Now let's examine how to configure a reverse proxy. We'll look at examples using Nginx and Apache, two popular web servers that can be used as reverse proxies. Here is a basic Nginx reverse proxy configuration. Within the server block, the proxy listens on port 80 for incoming HTTP requests. The server name directive specifies the domain name for which the proxy will handle requests, in this case example.com. The location/block defines how to handle requests to the root path. The proxy pass directive forwards these requests to the backend server, accessible at http://backend_server:8080. The proxy set header directives ensure that the original host and client IP address are passed to the backend server. Here's an Apache reverse proxy configuration. Within the virtual host block, the server name directive specifies the domain name for which the proxy will handle requests, example.com. Proxy requests is set to off to prevent Apache from acting as a forward proxy. Proxy preserve host is set to on to preserve the original host header. Proxy pass and proxy pass reverse directives forward requests to the backend server and handle redirects appropriately. In this case, the backend server is accessible at http://backend_server:8080/. Let's explore how to configure load balancing with a reverse proxy. This setup allows you to distribute incoming traffic across multiple backend servers, improving performance and reliability. Here's an Nginx load balancing configuration. First, define a backend server group using the upstream block. Each server directive specifies the address and port of a backend server. For example, 192.168.1.10:8080. Within the server block, the proxy listens on port 80. The location/block defines how to handle requests to the root path. The proxy pass directive forwards these requests to the backend servers defined in the upstream block. Nginx supports various load balancing methods, including round-robin, weighted, and IP hash. With round-robin, each server is selected in turn. Weighted allows assigning different weights to servers based on their capacity. With IP hash, requests from the same IP address are always routed to the same server. Now let's explore how to configure secure socket layer termination with a reverse proxy. Secure socket layer termination is the process where HTTPS connections from clients are terminated at the reverse proxy, which then communicates with backend servers using unencrypted HTTP. Here's an Nginx secure socket layer termination configuration. Within the server block, the proxy listens on port 443 secured socket layer, indicating that it handles HTTPS traffic. The server name directive specifies the domain name, example.com. The secure socket layer _certificate and secure socket layer _certificate_key directives specify the paths to the secure socket layer certificate and private key files. The location/block defines how to handle requests to the root path, proxying them to the backend server over HTTP. What are the benefits of secure socket layer termination? It reduces CPU load on backend servers, centralizes secure socket layer certificate management, simplifies the certificate renewal process, enables HTTP-based health checks, and improves overall system performance. Let's compare forward and reverse proxies to highlight their key differences and use cases. A forward proxy sits between clients and the Internet, representing clients to servers. In contrast, a reverse proxy sits between the Internet and servers, representing servers to clients. Clients are aware of and configured to use a forward proxy, while they are generally unaware of a reverse proxy. A forward proxy hides client IPs from servers, whereas a reverse proxy hides server IPs from clients. Common use cases for forward proxies include content filtering and bypassing restrictions. Reverse proxies are commonly used for load balancing and secure socket layer termination. Forward proxies are configured on the client side, whereas reverse proxies are configured on the server side. Popular software for forward proxies include Squid and Privacy, while Nginx, HAProxy, and Apache are commonly used as reverse proxies. Both proxy types serve different purposes in network architecture. The choice between them depends on specific requirements and use cases. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.